But if you don't have any Ubuntu system right now, it's perfectly fine. I would say install Ubuntu, don't do virtual machine or stuff because they're gonna give errors. So my experience with Linux is dual boot your laptop, install a proper Linux. I would recommend 14.04 if you're planning to use any of these robots. They're all on 14.04 Indigo. If you want to use the new turtle bots, the smaller ones, 16.04, but I would still recommend go for 14.04. Learn Indigo better, then move to Kinetic. Uh, what else? Yeah, so from the Linux point of view, has anyone used Linux before though? Like all of you guys have. So yeah, that's good. Yeah, you know the command.
I have a question. So, if I'm up and running with 16.04 from the first, will that create me some issues when I'm trying to access the other robots which you specifically told will be running on 14?
Yeah, for sure. Because those packages are for Indigo, and you'd be trying to run kinetic packages, so they won't communicate. Like their message type or something
Yeah.
differs every time. So I'll go through those things also, like how ROS communicates, and that's why in particularly you won't be able to run. Like some packages might run, but at the same time you will never know like which one will run, which one won't.
So, what do you suggest now? I should again triple boot and
Yeah, I mean, if you already installed for 16.04, I would recommend rather than working on these turtle bots, go with the new ones. I mean, in the end,
We have more of the new ones. So
yeah.
we have 3 new ones and 4 more will be assembled soon. So it will be, I mean, it's just easier to run. There are more options, I would say.
Later on, we can give them access to other stuff, like Docker and things. But
Okay.
for now,
Yeah. So now we also, yeah, Rishabh is working on setting up Docker and all the instructions so that you can run 1404 14.04 and ROS Indigo on 16.04 Ubuntu.
yeah. So the thing is, like Docker containers, you can use it later on. They kind of are virtual machines, but only for your terminals. And we were like working on those stuff, and we have a small script or something. You can just run those. Install Docker first of all. And we have like complete tutorial or README file on GitHub. We'll upload that and link it soon. So you can just install those things. So it doesn't matter which version you are running. I mean 14.04 if you haven't done anything yet, haven't installed Ubuntu, go with 14.04. If you have already installed Kinetic and stuff, then keep using that. Don't revert back. It's like a hassle. We'll just send you the link for the Docker container and you can run it.
Yeah, and also we're doing the things that we think are the highest priority and important right now, like setting up some of the robots wherever. But we might be completely be ignorant about the real issues that you guys facing. And we can help you, but we won't be able to help you unless you ask us for help. So don't. If you have some projects and you're thinking you'll be using these facility, like this semester, like you should try to come stop by, not at the very end, because there might be something not working, software issues, you're not familiar with Docker or something like that. It'd be better for us even to prepare for those issues and solve them in advance, so that when you come in and these issues are solved, or we can tell you exactly how to solve them. So don't wait until the very last moment, basically, and they're start coming in sooner than later. Yeah, that's.
Yeah, that's like very important because like if you waited for the end of the project or next semester, I mean we are here always, like we'll help you out, but sometimes like if we are not around and you face some issue, it's gonna take you a long time to figure out debugging. So,
Yeah, and Rishabh is a student just like you. So next semester he's going to be doing his thesis and defending. So his time is not going to be as available. I'm not as an expert in ROS, so I'm learning right now, and hopefully by the time I'll be able to answer some of your questions. But basically, it would be easier for you and for Rishabh if you ask questions this semester than at the end of the next semester.
yeah, that would be like really helpful for all of us. So like try early, start early. This robots will take some time. I mean it's not gonna be super easy. Believe me, I had so much issues with just installing ROS for so long time. So I mean, you'll face some issues, but if you try early, you have to give a lot of trial and error things. Like you'll uninstall Linux like once or twice for sure. You'll face some issues like that for packages. We did it a couple of times even right now. So I mean, it's okay. It's like you have to do it sometime. So it just takes time. Just think like that before starting. So plan it like if you think it's gonna project is gonna take you 1 month, just start 2 months before. So I guess we can start right now and um, yeah, if anyone joins us, we can carry on. So this is so yeah, again, welcome to Introduction to ROS, and in this tutorial, I'm just gonna go through the basics of ROS, like what kind of tutorials that ROS Wiki provides. You should go through what kind of tutorials you can like ignore for first, and like focus on basics and how to build ROS. So first of all, what is ROS? Like literally everyone's talking about ROS every time. Like, what is ROS? So ROS is just like an operating system for your robots. It's like a meta operating system for robot, but you could just imagine it's an operating system that runs on the terminal. So what ROS provides are why like we all are like, oh yeah, we should use ROS and stuff. It's like it provides you device control. So just like in Windows, when you plug in some device, right? You got install the drivers, download the drivers, you run those drivers. Now you can communicate to that device, like print. You can communicate to that printer, right? Just by downloading those drivers. ROS is exactly the same thing. You install those packages, you build those packages. Now you can start communicating to the robot. So like the configuration part for the robot or for the laptop, ROS takes care of that. Like you don't have to go into the specifics of hardware, like oh how Ethernet communication is gonna take place, what kind of data my Ethernet cable is gonna publish on the robot, or what kind of data my Ethernet communication is gonna send me from the robot, right? So those are the things that you don't have to worry about when you use ROS, and that's why we kind of like it that much. And the next thing is for coders, package management. For sure, we need like a lot of packages and stuff. Like we're using multiple robots, so the way you can manage your workspace, the way you could create your um, packages in ROS is like very structured. So you'll realize like it's a good way to do it. Okay, why? But why? In the end, again, like there's a lot of other platforms that do that thing. Like why everyone want to use ROS? First of all, it's open source, so all the packages are available. And like you might have heard that thing, like stop reinventing the wheel, right? Like don't do again that same thing that someone else did. So like let's say if I worked on something and I created a package for something, I'm just gonna leave it. Like I will upload it on GitHub or something, right? Like mostly I would do that. And if someone else want to work on that project, it would be pointless for him or her to work on that thing again what I did, rather than just install it from the GitHub and just like run it on ROS, right? So ROS provides a vast majority of open source like softwares and stuff, like for all the robots. Let's say if I want to do something like integrate Connect with Baxter or something, they're already packages. Like I don't even have to think about how I'm going to do it. I'm just go to the GitHub repository, read the README, done. I'll execute the commands. ROS will take care of that, right? So same thing happens with all of them. Like they have a very detailed tutorials for each robot, and that's why it's like very convenient for all of us because we can just go through those tutorials and run our things. So that's why again, like we can reuse the codes there. I can focus on what my project is, what my thesis is, rather than like doing everything again and again and again. So first of all, Linux. I hope everyone uh, knows Linux or something. Like it's very important. And first of all, like there's no shortcuts in that. Like it takes time to get used to Linux. I would say stop using the user interface of Linux. Just try to do all the stuff on the terminal. So if you want to get good on Linux, like just use terminal for everything. Believe me, everything could be done on Linux, like with terminal. Like even copy pasting some files, do it terminal. Like even compressing some files, do it on terminal. Like navigate through terminal. Just use terminal all the time because that's how you'll get good to the commands. Like you'll get how everyone is like you'll see some like really cool coders. They would be grabbing stuff. They would be like finding stuff on terminal and like coding and stuff. But yeah, I mean just start using it. It's gonna take a while. I mean, no one remembers the commands. Like even I don't remember the command. I Google it a lot. So you just have to be very good at googling stuff. And this is like a small link. It's not. I mean, you can find it anywhere, but you can just go through this basic tutorials if you are very new to Linux. But if you know Linux, just skip it. It's not important. But if you just have like no idea how Linux works or how the terminal communicates, then go to it. Again, like for someone who came now, I would say start using 14.04 and ROS Indigo. That's what our most of the robots are compatible. But if you already installed 16.04, don't revert back. Start using Kinetic. I'll be giving the tutorial in Kinetic because again, like I have 16.04 and I work on Kinetic most of the time for the new packages. Um, but if you have 14, go and use it. And later on, we'll upload the Docker container that I was telling about. It's like a free open source platform again, and you can read about it later on. But we'll just upload all the README files and the scripts so you can run it easily. Should not take you a lot of time. But if you face any issues, just let me know. So I'm personally developing on that part, like I'm doing that. So just mail me or use my GitHub account or create an issue there. If you face any issues, I'll try to solve it. Okay. Do anyone know what's Catkin now? Because you're gonna see Catkin everywhere. Like before starting the tutorial itself, let's go through what's Catkin. Anyone? No?
It's like a ROS build where you can build a package and navigate inside a package.
It's a ROS build, yeah. So it's like just like CMake. When you do CMake for C++ files and stuff, you kind of like what you're doing is creating targets from the raw source like codes, right? So you have a Python file or C++ file, you create an executable or target from that. So that's what cat can do. Like Catkin is especially for ROS because I think they just wanted to have their own management system and stuff, like control their variable links and all those things. So that's why it's like essentially it's just like CMake but inherited to ROS, so it's easier for them to work on it. They used to use ROS build before, but then they moved to Catkin. So I guess it's fairly simple enough. Don't go nuts about it. Like don't be crazy that oh what's Catkin and stuff. It's just like CMake, just like a building system. You don't need to know much about it. But if you wanna read more, just go through the link I've attached. And so first of all, I'll upload all the files like PDF or PPT online. So don't worry. Okay, now starting with like ROS. So the way ROS communicates is it always has a ROS master. So you might not see a lot of times when you do tutorials and stuff, but there's always a ROS master. So ROS master is something that takes care of the communication between all the nodes. So consider this as like a block system. Like there are different blocks and how these blocks communicate to each other, right? So ROS masters take care of those communications. So what ROS do is you launch a node and each node is assigned a task. Let's say node 1 is assigned a task to publish the messages for arm position. Node 2 is assigned the task to read the messages from the camera. Node 3 is assigned the task to read the messages from the force sensors in the robot. So these are like the nodes that are running on ROS and like on the robot itself. And they are communicating with the robot. Sorry. So these are like running on our system and they are communicating to the robot. So the hardware is basically coming from node side. And here the master's work is just to make sure that everything is synced up. Like they are communicating, the laptop or the computer knows that these many nodes are running right now, these many nodes are communicating with each other. So master is always running. Sometimes you don't have to run master, like most of the times you don't have to run master specifically. All the launch files that you execute kind of like run master by themselves. So for if you're going to use ROS run, some commands like ROS run rwis, they don't know what to do with that. Like they need master and stuff. But some of the commands, when you code it yourself, you can actually include the ROS master launch before. So most of the launch file you will never run ROS master. Actually, ROS launch always executes its own master, so you will never run it. Okay, so let's go through the tutorials now. I haven't created my own tutorials because these are the best ones you can find. Like straight up, it's the easiest thing. It's the best thing you can go through. So and the only thing to learn them is just like go through them, like literally try them at least 2 3 times because you're gonna face so many issues in the first trial. Like it's not gonna work perfectly in the first trial. Like ROS install itself is not gonna work in the first trial. Like so whenever you open a new terminal or something, right, you know the bash file. So either you could include these commands in your bash file. Like there's a way to just include them, like source this file. And if you don't want to do them, just make sure that these files are sourced. Like you can echo ROS package path or something like that. So you can always see what packages are sourced right now. So most of the time, the problems you'll be facing while running those tutorials is like it can't file that package or something. And you'll be like, oh no, I'm like right in the directory of that package. Yeah, you are, but you haven't sourced that package. So ROS doesn't know when you try to do ROS launch or something that this particular executable file exists or not because you haven't sourced it. Simple as that. So make sure you source everything. Like if you want to use that, source it. And don't source it like if you have two packages with same named or something, don't source them two times. Like they'll create conflicts and stuff. So don't do that. But yeah, like make sure this file, like particularly this one, it's always going to be opt ROS. Then Indigo if you're using Indigo, Kinetic if you're using Kinetic. Don't use the new version. I don't remember the name, but that's debuggy. Don't use it. Yeah. So yeah, don't use that one. I mean, 17.10 also don't install it. Um, so yeah, just source these files for sure, like this bash file for sure. And then when you create your workspace, you create it like this. So make directory dash space parent directory. So you create two of them together. Catkin workspace src, right? So you have a Catkin workspace and src. So all you need for creating a Catkin workspace is just an src folder. So you have a folder named, just you can name it anything. Like you don't have to name it Catkin workspace. Just name it anything. Like robot one, robot two, Baxter, Puka, Turtlebot, anything. So just name it with whatever you want and create a src folder in that. And then you can just do it Catkin make here. Just go inside that folder and do a Catkin make. Then it will create all the devel and build files folders. So you can just use them later on. But yeah, that's the idea. Like later it will come into the tutorial. But yeah, I mean this is something that you should always do, even if the tutorial don't talk about it. So let's say in like for future tutorials, you will figure out that you have to work on turtle bots and stuff, right? Like the simulation part. Most of the time they will tell you, oh yeah, you can go into that and see. But I would recommend always do this. ROS node list. Whenever you run a launch file, just type this command for your own knowledge. Like ROS node list. Just see what nodes are running right now because you are curious, right? You are here to learn, so just see what nodes are running. Then go into the info part and see what each node, like how each node is working, and try to map it out, like how they are communicating. There's always a tool RQT graph which will tell you that okay, these nodes are communicating with this one, this node is communicating with that one, this is the messages, this is the topic. But I would still recommend sometimes the RQT doesn't give you all the data, but this one is like complete information. So I just type this every time just to make sure that I'm doing the right thing. So it's the same thing. You do ROS run, you have installed those build like beginner's tutorial package, and you go there, you do this like turtle sim. It will tell you to do ROS node list. You will see okay, and now there's ROS out. ROS out, you already saw that it's just because of ROS core, and this is turtle sim that you just kind of launched, right? So you know that okay, yeah, I did that. But now go into the so they told you that you can go and see ROS node list, but you can always go and check the like ROS node echo space slash turtlesim just to make sure what turtlesim is doing. Like you're curious, right? So just go there and check it. And so they never do it. Like I don't think they'll tell you about like you don't need to do it, right? Like it's pointless for you to do it. But if you want to do it and you can learn something new that you can see, okay, yeah, this is how the turtlesim mode was communicating. So future on like if you want to develop your own packages or something, it will be much helpful. So yeah. Then again you can rename the node list or something. It's important if you are having a lot of nodes that are essentially from the same name. So like turtle sim node and you want to run two or three of them, you can just give them like a slash dash name and stuff. So it will create it in the different namespace. So this is how you make sure that none of the nodes coincide each other. Like if there are two nodes with same names, it's gonna be an error for sure. Like this will happen with all joint trajectory stuff and all those things. So a lot of times this is the problem. You launch some nodes and two nodes are having the same namespace and ROS doesn't know which one to publish on, right? So that's why ROS node list, ROS node echo is going to be helpful that which node they're publishing on and stuff like that. Topics. You run that again, you see this, and now RQT graph. That's what I was talking about. So this is what RQT graph tells you. You know, this was the node, right? You launched a ROS run command there, and you launch these two nodes, and now you are seeing how the nodes are communicating. So RQT graph, they told you that okay, this is the kind of topic that they are publishing on. So what essentially teleop is doing is teleop is publishing its messages on turtle one slash command velocity, and turtle sim is just reading that topic, and that's essentially the whole point of ROS. ROS is just enabling you to run these nodes and publish commands on this. So whenever you run Baxter, you know, or like Sawyer, you know that Sawyer reads on joint velocity trajectory or something like joint with velocity, joint positions, joint torque values. So these are the topics that Sawyer reads. So all you have to do is publish on those topics. So if you want to do like execute a particular command, you create your own script or something, you give the particular commands on those topics and run it. So now you know you're publishing on that topic. You don't have to make sure that this is reading it or not, because that's how Baxter or Sawyer was created. Their internal PCs are supposed to read from this topic. You're just publishing on those topics and they're going to work. Sometimes there will be errors for sure because you're publishing it in the wrong way, the ROS timer and all those. But again, that's why you have debugging tools here like ROS topic list or echo topics. You can read that how they're going to. So help command will tell you what all commands exist. Use it. It's like the same thing as terminal. um, echo. So this is the like when you echo the command velocity itself, like that particular topic itself, you will see how the velocities are published. So you see like x 2.0, x 2.0. So this is like how you're publishing the commands on that topic. So and this is exactly how it should be. Like you can't be like just x 2.0 and you don't give any xyz angular at all. Like you have to give it in the exact same manner because that's how they're reading it. So just give it in the same format and you will be able to run the robot. So it's very important that you do that thing for all the tutorials. Like go through ROS node list, ROS node echo. Echo is the best command that I use. Like I just want to see how they are doing stuff. So echo tells me a lot of things about that. Info tells me a lot of things about that. So I just use both of them a lot. Again, RPT graph. So for high level, that's how I start. Like if I have some error, if my package is not running, I'll do RQT graph first to make sure that every connection is there, everything is connected, everything is like cool, it's running smoothly. From overall perspective, if I know that okay, now I see that there's something missing, like this, I know that turtle, teleop turtle should publish something on that topic, right? Because I'm reading it, or teleop turtle is publishing on turtle sim, but there's no line between them in RPT graph. So I know that okay, this is wrong because they're not communicating anyway. So now I go into the topics itself or the nodes itself and run the info part that okay, who's the subscriber, and I will like debug from there on that okay, it's supposed to have a subscriber called Turtle Sim, but there's no subscriber called Turtle Sim. So I launched it wrong. I connected it wrong. So now you know how to solve it. But again, yeah, simple things. Same way. Messages is like the way you publish stuff. So ROS provides. So you remember when we were doing that Catkin package creation, you also did standard underscore messages. So that's where you kind of like link them to the ROS messages that are available to you. So what ROS messages is, it's like ROS follows a particular set of, it's like a pattern or something to publish the command. So all kind of twist like geometry messages, it's gonna be in this format. It's not important that all the robots need all the information, but this message, this standard message, it's going to be in this format, and you have to use this standard message in this format to run the robot. If you just like, if your robot just moves in X direction, you know, there's no Y direction, it will always be zero, but you still have to publish it in this format. Give Y 0, give X the certain value you need, and that's it.
Can you please zoom in?
Oh, sorry, yeah. Is it good? Or
Yes.
okay, so these are basic things again, like linear velocity, angular velocity, all these things. Now publish. Okay. So sometimes I just don't wanna. code entire, like I don't want to create entire um, Python file just to run a robot's axis, one axis by like 2 degrees or 5 degrees, right? I know nothing is gonna hit. I know nothing is gonna. So I just publish on that topic. I know that this kind of messages they are taking. Like I know that okay, I want to publish on turtle one command velocity. I already knew about that, and I know it's working on a geometry message twist. And then double tap it, it will just give you this link. Like I don't remember that. I don't remember how each message is formatted. Like unless I'm gonna code it in Python, I don't remember. I don't have to remember. I just double tap it, gives you that okay, yeah, this is the format. You publish it, you're done. So
You
here
mean
you
the
again
tab
saying like
completion sort of?
yeah, it's tab completion. So double tap is usually for tab completion there, and these messages, standard messages, whenever you double tap, they'll just like give you the standard message. So here you can see that it's not giving just 2.0 and 1.8. It's the older version, right? So for newer version, you have to follow the certain message like format. So you can't be just like dash like slash 2.0 bracket close dash. It's not gonna work. It doesn't know which topic you're publishing or like how you're publishing it. Yeah, so
So this messages like the XLD coordinates here are really to a kernel. But if you wanna give it like immediate like make a script or and then give it like that, so how do you do that? Will the format be the very same or
yeah, format will exactly be the same. Like
so will we be separating by comma? Because here like we are separating two matrices by booleans.
I mean, it's the depends on the programming language you are using, right? So you're just gonna import those geometry messages, and you will see how they like Python. Let's say Python, you create a matrix like this, then you create a matrix like that.
No, but like two different matrices. Like for example, the will be contain a variable and then give that variable or
I mean, you could do that. Otherwise, it's usually it's usually the same format itself. Just give the space and just tell them that this is like just exactly the same message format. Like you will call those, like you will import them first of all, and then go to them. We'll talk about those things later on, like in the tutorial. But before going into the like actual coding aspect, like changing the Python, like working on the Python scripts or C++ scripts for controlling robot, I will still say just use these things. Like because most of the time we start with that part and we never know how the ROS was communicating exactly, and we just like stuck in the loop again. I just have to go through these tutorials again because I never practiced them. So whenever like on the next tutorial when we'll be working on Baxter or Sawyer, sorry, I will show you all those aspects like how it's actually communicating and how we are actually publishing on it. So that's why like you have weekend to go through it, go through these small things and like make sure you are aware of how ROS works. And later on when you are done with those aspects, we can go into the detail on Wednesday that how you're going to publish it in Python now, how you're going to publish it on C++. Or you can use both of the methods. So I mean, yeah, the same stuff. Use them like to debug and everything. So you will realize some of the commands. And always just like use RQT graph, topic echo, topic info, node info, all those things they're helpful. I never use this one. It's mostly for making sure that the data is on same page and stuff. If you're having multiple devices connected, it's gonna take you very but otherwise it's fine. RQT plot is something just like a plotter in MATLAB. Just like, when you plot in MATLAB or something, you can use this RQT plot here. So if you have a particular data that you know it's gonna plot it, you can select from that topic here which topic you want to plot. So if that topic is changing the information, it's just gonna give you there. So you can check this out. And I think it's the older version, but don't follow the commands here. It's like exactly it's hydra or something, but you can check this out later on. Okay. So again, you did this. Oh, we already went through this one. Sorry. So services and parameters, just like topics, but you control them much better. So you can list them again like this and see how the services work. So services are something that exist there. They are not running, but you can call them. So based on your calling function, it will execute them. So like here, you call a service clear, right? So clear will just like clear everything up that you were doing before. So the lines or markings that were running will just like clear them up. The spawn, it's gonna bring a new one. If I remember correctly, yeah, it's gonna spawn a new robot and stuff. So there are like certain services that you create when you create your package or something. So you link them. Like for Baxter, let's say I have a service called Open Gripper, Close Gripper. So I'll just like call that service. It will open the gripper, it will close the gripper. So I don't have to go and deal with that. Like I know it's like two-stage thing. Like open it, close it. I don't have to control it. I don't have to control the velocity. I don't have to control the speed. Just call that service, you're done. So that's how services are used most of the time. Simple things, just like how to relate. Um, yeah, I mean, basic commands that just execute something you have defined before. So you have to create services though. There's like you'll go into the structure later on. Like step by step we'll go. Like for this weekend, I would say just go through basics ROS because I'm assuming you all are beginners. But if you're not, then for sure you can start with intermediate. But right now, just go with this one beginners tutorial and focus on the ROS structure itself rather than details of ROS. I mean, if you're a good coder, you just have to understand the structure, and then later on, it's going to be very easy for you. But structure itself gives you the parameters. Sorry, I just skipped it. So, as you can see, there are like always a lot of parameters in anything that you do. It's like a more complicated one here because you have colors, you have number of turtles, you have like size and grid, all those things. So you can set those parameters or like by using these command functions or something like that. But you have to create parameters again. So in your SRC, in your package, in your like package itself, you'll have those parameter folder, services folder, messages folder, configuration folder, SRC folder, again launch files and all this. So you'll do that, but for right now, just focus on how to call parameters, how to debug parameters, how to like publish parameters, how to clear them, all those things. So it's very basic. Just do that. Should be easy enough. And yeah, this is another thing that's important. Like, so how you save the parameters is like you create a configuration folder. So parameter folder is just like configuration folder that I was talking about. So it's like a config folder that saves the YAML file. So YAML file are the configuration files, and you have a format again in YAML file how to save those configuration files. So for geometry messages again, you use that format that okay, I have to publish it in this format, so I'll just create it. It's like a README file, but you write it down in a certain format. So ROS, whenever you call that YAML file, it reads through that and it knows that okay, these are the configurations. So for all the robots, there has to be configuration files. Sometimes they're just like deep enough in their repository so that you don't have to worry about them. But let's say if I'm trying to create my own package for this robot, then I have to set the configuration file that okay, this joint is at its initial position is 90 degrees. This joint is at this degree. So robot knows or the ROS knows that okay, yeah, this is my initial configuration. That's from where I'm going to move. So parameter files are used for a lot of things. You can call other like link other repositories too sometimes with parameter files. So that's there. But yeah, just open some parameter files. I would say just go through that YAML files and just open them like on Vim or gedit, whichever reader you use. Just open them and read them like how they work. Like try to understand their structure, that what they're trying to do right now. And should be easy enough. ROS launch. Okay, so I would say, okay, I always use ROS launch rather than running each node. Like I don't, even if I'm running just like single node, I kind of try to use ROS launch. So what ROS launch do is rather than running like each command every time, like ROS run this, ROS run that, ROS run that, you can just create a um, single launch file and include all those ROS runs or all those node executions in that launch file. So you like launch all of them at once. So you don't have to worry about that which nodes, like you make sure that each node is running or not. You just launch them, they are running all the nodes. And you can always go and debug now ROS node like list, then you know that okay, they executed correctly or not. So now we know. But I use ROS launch because it's much easier for me to change something. So um, if I'm changing something like in a particular node or something, I know that I just have to comment that part out and still run the complete launch file because I'm not using it anymore. ROS launch is like my way to create a structure on my nodes. Like I control my nodes using ROS launch. You can create namespaces in ROS launch. Yeah, that's very important. So let's say if I have two Baxter arms, right and left. Usually it's by default in namespace right arm, left arm. But let's say you create your own, so you bring another Sawyer here. Both of them are going to be in the same namespace, Sawyer arm. Now you want to run both of them together from your own laptop. Run the launch file of both of them together. Then you create those namespaces. You create a namespace for right arm, you create a namespace for left arm, and run the same file. Like literally, you call the same file but different namespaces. So now it knows where to publish it. When you give a namespace, it will just add that namespace in front of all your node topics and all those things. So now your nodes would be right arm, all that Sawyer files, left arm, all that Sawyer files. So now you have different robots itself. Like that's how convenient namespaces are. So mostly I work on ROS launch. I rarely run anything using ROS launch. Even if I have one like node, I'll just include it in ROS launch. I can set parameters and stuff. I can call parameters in ROS launch, so it's much more convenient. Again, source everything. So this is like the format, yeah. So this is what I was talking about. This is exactly like they have the same packaging. Are you seeing it? It's exactly the same node that they are running, but they just create these namespaces. So now you know that there are multiple robots or multiple turtle bots that you can control now, and they can remap stuff. Like okay, one topic is published from here, you can remap it to there. You can make sure the communication happens by doing those things. So that's why launch files are very important. Like you'll see launch files for all the robots. They work essentially on launch files. Again, yeah. So, but yeah, whenever you run ROS launch, now it's the time you have to debug again. Because when you run Node, you know if it launched correctly, you know it's going on perfectly fine. But you do ROS launch, now you're doing customization. You need this part, like you're connecting something, and now you have to debug if it's working or not. So that's why these things that I was talking about before, publish, echo, list, they are going to be important now. And they just run like this: ROS launch, your package name, and your launch file. So don't worry about the folder in your package. You keep it. Just yeah.
Um, here the node key is same.
Which
Like
yeah.
although we made like two use cases, servicing one and servicing two,
Mm-hmm.
but the node package is equals like everything inside is same. So how will it know that which namespace is for which one because the topics and the
So no, it's essentially running the same node. It's literally running the same node. It just adds slash turtlesim one there. So now your robot has to be configured to read from turtlesim one. So it created like a. So this is your one node n1 n1, right? So you try to run both of them, give you error that it can't run any of them. So D1, D2. So now you know D1, N1, D2, N2 they are running, right? But this is in your laptop. So your laptop launched two nodes. They are doing exactly the same thing, like exactly the same thing. They're publishing the same topics. They're publishing the same thing. But now all the topics are also under this namespace. So that's how it exactly works. So T2, T1, T1, T2, and everything here, like all their topics they're publishing, all the services they're calling, and all those, they're gonna be named under T2. So created a block itself, and there's no communication unless you mention from here to there. So ROS creates like two separate segments of the same nodes, and now you want to communicate to your robot, right? Now you want to say that okay, Sawyer should read from that robot, Sawyer should read from that. So now you do it from here. Like you say that if you already figured out the mechanical communication part, you connected Ethernet and stuff. Now you tell like code Sawyer to read from this package, like N1, sorry T1, and for his to read from T2 slash whatever it was reading before. So you just like give that namespaces even to that. So like you map it correctly. That's how you do it. But it's the same. Like literally, it's the same topic. You'll go to the topics and you'll see they're publishing the same format of data. Just they have this T1, T2 in front of them. So that's all. So it creates two instances. but they are exactly same. So you don't have to code again.
And rules are different too.
Different in the sense they are running in a separate space. Unless you give them any communication details, they're not gonna communicate or they're not gonna create any issues. They're gonna work on their own. Like this node will also publish its topic. This node will also publish its topic, but they are same topic but under different namespaces. It's just like creating instances, like classes, right? That's how you do in classes. Like you create class member of class one, sorry, member one of class, member two of class. They have everything. They call the variables, they call the functions, all this stuff, but they are still different, right? That's what namespaces do here. So exactly same thing. And you mapped it so you know that okay, yeah, you will see that here you will publish on one topic, but it will run the other turtle bot too. That's because you mapped it right here. Remove this, it won't do that. So like mimic, you did that part, like input from this is output from that. You try to publish it on this, it won't run on that because you mapped it in a certain way from here to there, so you know which is subscriber, which is publisher. Again, ROS topic or ROS node info, go and check it out. Like just make sure that everything is running as per your um, requirements or something. RQT graph again, very useful. Just run it all the time. But, skip this. You don't need to use raw CD. If you're comfortable with Vim, you're comfortable. You'd like to use Emac. No, sorry. Uh, Gedit or something, or any other like Atom or something. I don't know. Like I personally use Vim, but I was forced Vim. I used to be a Gedit guy, but then like my internship people they forced me to Vim. But yeah, you can use any of those things. You don't have to go through this. Raw CD is just like Vim. So in the end, it's Vim. So I use it, but you don't have to use it. If you don't remember the commands, don't use it. Take some time. Again, messages and services. Uh, Messages we talked about. It's gonna be the same thing. So I'm gonna skip through this part because I want to discuss in the last segment. But okay, so I would say run both of them. Like try to run these files, so you will get an understanding by you get an understanding of how the scripts are going to work now, like how you're going to write those packages and all those things. Like here, like you'll use literally Python here now to start communication and stuff like that, and you'll use so you imported that string, right? So here you do that thing like standard messages dot message string. So you know that you're calling on or you're working on string, and string is supposed to be in this format. That's how you publish it all the time. Or sometimes like I get your question that you are confused like whether we should give a space or enter or something. Just try. Even like sometimes I'm confused. I'll just like type it out and run it. If it's error, like I'll check out the message. If it's like not in the same format, I did something wrong. So I'm not a really good coder in that sense. Like I don't know a lot about Python in general or like C++, but I know the structure of ROS, so I work on that part most of the time. But still, like you'll get used to this thing and you will start working on those things. ROS is basically made for everyone. Like I did mechanical engineering, so I started with that. Still don't have any issues with running robots and stuff. So as a mechanical engineer or any other like my friends they're from biotech or something, so they still use robots and it's much more easier for us because we don't have to go into the details of like hardware software communication and all those things. But meanwhile by working on that you will start learning Python and stuff easily. So I mean yeah, we'll just go through them basic Python stuff and run those things, listener and subscriber. Then you like if you're working on Arduino or something, you can see that you can do all sort of like cool stuff called raw serial. So just like send data from um, Arduino to your PC via raw serial and work on that. So I mean yeah, just try those things like in both. I would say both, or you can skip C++ if you don't like. I personally like Python more, but because I'm mechanical, but some like C++, just work on C++. Python always you have to create that executable file to make sure. C++ is directly linked by CMake but for Python you have to do that. So chmod, chmod plus x, all those things you have to do it. Tutorial talks about it, so just go through it. It's the same thing. Tries to like run the publisher, you'll see that it publishes here. Run the subscriber, you will see that it's listening. Again, it never says here. I would say just type ROS RPT graph, RPT graph. Just see how they are communicating. So you have two nodes, listener, subscriber, publisher. You will see how they are communicating, what kind of messages are going to. I don't think they talk about it here. Like they don't tell you to do that, but for every tutorial, just once type that, like ROS node list, ROS node info of the different like nodes you are seeing, ROS topic list, ROS topic info, all those things. So just like type it. It's not going to take you a long time. So I guess I would recommend you to go through these like 13 tutorials first, and service client we can talk about it later on, like on when we'll work about Sawyer and stuff. We can go through them, but I mean, yeah, they go through all the tutorials first, and then they tell you how to go through ROS wiki. So it's pointless there, but just use those things. Like even if you have done it before, I would say just recommend just do it again this weekend. Should not take you more than like 1.5 hours at max. If you are curious, 2 hours. Like if you type every time, literally what I said, like node and list and like play with it, 2 hours at max. But just go through it and complete by like 12, like sorry, yeah, till 13. So I mean we can discuss it later on, because this is these first 13 is like you will face some issues and you will stop. So if you just like go through them together, this is all you need to run Sawyer. And we can run Sawyer after this. I'll show you like how to use just this basic knowledge on run Sawyer. And later on we can talk about more about like how these scripts work, how the SRC files and stuff communicate. But for now, I mean this much is good enough. But I would highly recommend install Ubuntu dual booted unless you have two laptops. And run Indigo again, but I'm using Kinetic. You can use any of them. It's okay. Both of them are stable right now. And yeah, I mean that's essentially it. Like go through them, and you, if you face any issues, just let me know. So in the end, we had some discussion about the ROS tutorials and stuff, like how messages communicate, publish, and echo. So those 2 3 commands like info, list, echo, publish, just use them a lot. I would say tutorials don't talk about it, but that's how I learned ROS. Like I went through all those things again and again and again, because like most of the time I was debugging stuff in my internships and stuff, so that's how I learned it. And yeah, don't feel shy to mess around stuff. Like in Linux itself in general, like don't feel shy to go into the bash file and just like erase anything. I did that. I did that. I was like so curious. I just like literally deleted everything sudo and I was like, yep, install Ubuntu again. So I mean, there might be other solutions. I didn't knew about that before. So I don't feel shy. Just like go mess around with things, like change the scripts, change the launch files, change the try to see what happens. Like you have to play around with those commands and stuff. It's very interesting because in Linux, a lot of commands can come patched together and still work. So sometimes you don't know which combination will work or not. So I was like sitting with Ivan or something like Ivan one time, and we were just like discussing, will that work? And we're just like literally trying that. Okay, I know this command works separately. This command works separately. What would happen if we combine them? So I mean, like try those things. Like it's something very good. Like Linux has a lot of freedom. Use them. Use terminal. Don't use UI. Like it's pointless to install Linux and then go and click on stuff. Like don't do that. Like if you want to run some script, just like use the run command. Be patient. It's not gonna run the first time. Like never. I mean, if it runs, it's perfect. Like nice. But for me, I think I went through the ROS tutorials at least 3 or 4 times, like the same thing again and again and again, because I had no clue. I did it once. I stopped for 2 3 months. I had no fucking idea not what's going on right now. So I just like I had no clue. So I went through them again. I went through them again. So yeah, I mean you have to do it a couple of times. Don't worry. If you feel any like if you think you are facing any issues or something, um, you can go to our website first of all, and you'll find my contact info there. So just mail me. I'll try to reply all of them, like all of you guys together. Like I'll create a list of questions and like what everyone is facing. But it depends on your input. Like if you have any questions, I'll prepare an Excel sheet or something and try to answer them together. But at the same time, there's like a lot of wikis out there. So ROS is a big community, and you can have like a lot of specific ROS related questions and stuff. So just go online, just Google stuff. You'll find solutions for most of the things. Yeah, the don't panic thing is the most important because like if you face some issue, don't just give up. Like you will run it 2 3 times, it won't work. You will just like that's what I did at least. I was like, I'm gonna ask someone who knows about this stuff later on. Never works. Like okay, yeah, he's gonna give me the solution. Next time I'm gonna face a different problem for sure. And then I was like, okay, I'm gonna go and ask him again. Like that's what like. And then they were like, yeah, it's like he knows nothing right now. He's just like doing what I'm trying to do, like what I tell him. So mess around with things. It's not gonna work again. I'm saying you, but just try to change those things. Like just try to change parameters if it's not working. Just try to like Google stuff. Like that's how it works. Like give it some effort. But in the end, if it doesn't work, just ask me stuff. But yeah, at least give a fair amount of input that you know what you're doing. Like if you're facing some issues, we all will, but at least give some input before just like sending the question out. So also you can go to our website if you are like interested in working on a particular robot. So we have tutorials for all of them, like individually. So Kuka Iowa is not on ROS, so I'm not gonna assume you're gonna work on that soon enough. Plus also for running Kuka Iowa we need much more like yeah, we need like much higher level of trainings, like our best robots kind of thing. So again, like go to Baxter. We have some links here. Baxter Wiki, ROS tutorials again, Move It tutorials. Like Move It and stuff. We'll talk about it later tomorrow, like Wednesday. RWiz, Move It, all those things like UIs for ROS. But yeah, I have some small instruction how to set up your workspace. So if you are interested in a particular robot, you complete your tutorials. You would be like, yeah, Wednesday I will get an access to the robot. So just like start doing it. Talks about how to get an access for the robot. And since you're already in the flow of the game and you want to get access on like next week itself, just go through them during the weekend. And turtle bots are the simplest ones. So if you want to start on something, if you don't have any particular project in mind, go with turtle bots. Two actuators, not going to harm anyone. It's perfectly fine. Baxter and Sora are also good, but I would still recommend turtle bots for learners because you just ran turtle bot. That's exactly what they are going to do. What you run on simulations, that's exactly what you could do on the like, same geometry publisher, like twist message and all those things. So it's exactly the same. Also, we have some workstations here. So we have ROS workstations with Wiki, sorry, 16.04 kinetic. So if you think your system or you don't want to install Linux, you have some data on your system and you don't want to install Linux right now, you can reserve it. I think most of you have access for this now, or you do, right? So you can reserve it. Yeah, you can like if you don't talk to Ivan, he takes care of those logistics and stuff. Um, so we have these laptops and like computers. You can just go and book it and work on it. Like if you don't want to install on your laptop, yeah, that's like most of it. And yeah, I hope you'll like try all those things. Start working on Linux and we'll run Sawyer on Wednesday, so I hope you'll be here. If you have any questions, just mail me. And meanwhile, I think we still have some time, so if you want to ask something, like how to proceed or anything, then yeah.
For Sawyer and Baxter, we need a specific version.
14.04. Yeah, they run 14.04.
No, Kinetic or Indigo.
Oh, so first of all, like whenever I say 14.04, it's just gonna be Indigo for 14.04. For 16.04, it's gonna be Kinetic. You can't run them separately. You can't run either of them in another. So yeah, they are on Indigo. Their packages are stable on Indigo. Their packages are there in Kinetic, but I won't recommend doing that. Plus, at the same time, the same thing I was saying that okay, we'll try our best to run the Docker or to make the README file stable by or like. So I created the package, but I still need some inputs on the README file because I assume some commands that people would know, but sometimes when you install it, you don't. So I will give it to someone else also and the version that I have and try to build the README soon enough. So if it works, it's good. Otherwise, we'll try our best to give it to you by Monday, so you can try running it like by Wednesday or something. I'll need the weekend for sure for updating the README. There are also some commands that I'm missing right now, so I'll try that. But yeah, essentially, you'll be able to run it by like Wednesday for sure. Like I'll make sure of that. Plus, if anyone has Linux, Mac, no one is using Mac. Okay, So I have another Docker that can run essentially 14.04 on Mac with all those things like Linux, sorry, Indigo version and all those. I'm personally using that for myself, but still a lot buggier than the Ubuntu system. But if you're interested and if you want to give me some feedback and stuff, if you want to run those robots on Mac, you're welcome. Like I'll send you the link. It's not like public yet, because it's like we are facing a lot of issues right now. I'm just like I'm also trying a lot of things on this, but my friend like he's developing it, so I'll send you the link if possible. If someone is curious, just send me an email if you're curious about the Mac version of Docker, and I can send you the link. But for Linux systems, it's gonna be easy. For Windows, I don't know. I mean, they have Bash, but it's I can't even install like do basic stuff in Windows right now. It's like a lot of issues, exhaust and stuff. So I don't think I'll be working on that. But if you have Linux, don't worry about the version. I have Docker for both versions. So if you're running 14.04, you can run Docker for 16.04. If you're running 16.04, you can run Docker for 14.04. So it should be fine enough for you. So yeah, thank you very much. I didn't execute any commands here, but because I just wanted to talk about the like I don't want to do complete tutorial one by one here because otherwise you won't learn if we just like do whatever I type here and you type again. So just go play with stuff and you'll understand. And we'll run for sure like Sawyer on Wednesday. I won't allow you to run Sawyer to be fair. Like just to be clear, I'll run Sawyer and I'll show you what kind of messages and communication is going on. But if you're curious and if you want to work on it, like we highly recommend that please do this. Like please go through the tutorials. You know how to get access. We talked about it there, and like we'll give you the access. We want you all to work here like as soon as possible. Don't delay your projects later on. You know, like that's what I'm saying. Like in the end of semester, robots are gonna be booked, and you're gonna be like, oh shit. Like,
I have a question. So, what's the difference of using CPP and Python?
it's just your preference.
Okay.
Yeah, I mean, some people don't like Python, like coding Python. Some people like, and some libraries by default are in C++, so then you have to use C++. Like, let's say Baxter. I don't remember. I think they're Python, yeah. But some people would be like, they have only, yeah, Baxter and Sawyer are Python, but some robots would be just giving you the libraries, their libraries in C++.
So is it possible to make both? Maybe I use publisher for
Oh
CPP
yeah,
and
oh yeah, for sure. That's why it's very free for ROS.
Okay.
Like that's why if you're just working on these commands and you don't tend to inherit their classes and stuff, or sometimes if you want their classes in your codes, if you don't want to do that, just publish, just work on the basics that they have given you. It's gonna work perfectly fine with either of them.
Okay.
Yeah, it's no difference at all. So anything else? Sure. Thanks again for joining. I mean, you want three of them? Why do you want three of them?